Hey guys, Will Hater here. Do you remember that really tough, excruciatingly difficult packet tracer from CCNA 2? Well, it's back and with a vengeance. Here is CCNA 4 and we're dealing with it once again. This is packet tracer 4511 for CCNA 4. Oh, let's get going. We have this network here, the 172.16.128.0 network. It's a /19, and we want to be able to cut this up into two separate subnets, and we're going to assign the last usable IPv4 address of the second subnet to the gigabit Ethernet 03 interface. This is on branch. Assign the last usable IPv4 address of the first subnet to gigabit Ethernet 01 interface. Okay, so let's pull out our sheet like we always do. Open her up. Okay, so I've got the network in here. And to subnet, of course, you just move the network portion over one or however many you need, and then you keep on going. So we're just going to borrow 1 bit. So if we're at the 19 bit on this, so 32, we're just going to jump over to that 16. Enter, you'll see that changes that ANDing process. Now, this would be our first subnet. Okay, first subnet. So let's do this one right here. 172.16. What now? 128. No. Okay. Right here, it'd be our last usable. So our IP range is 172.16.128.1 all the way up to 143.254. Okay, so thanks for yelling at me through cyberspace. I would have got it, right? Yeah, maybe. Our subnet mask is 255.240.0. And we can ignore this is going to be for your IPv6 addresses, which we have to do as well. But don't worry too much about that. All right, so what are we going to do to figure out the second one? Well, just look at your broadcast address. That's the last address before it flips over. Okay, so if we add one more to this, it's going to be, this will turn into a 0, and this will get incremented by 1, right? Right. So we just go up here and say 144, because that would be the next range. So you can see our network address would be 172.16.144. Our range would be 144.1 all the way up to 159.254. So we copy this up here and just change this to a 59. Is that right? Yeah, 59. And then this can just get copied up here. Okay. What else do we need to do? Document, we did that. Configure. Okay. Oh, well, we can do this too. We'll just add this into our. It says assign these addresses. Come on. To gigabit Ethernet 00 and gigabit Ethernet 01 respectively. So this one will be there. And this one goes here. Anything else? Okay, we'll come to the rest of that later. Drop this down. Let's get into our branch, and we will interface G00. Okay, so we got our points there. Now let's go over to G01. Just up arrow, and I think this all we're going to do is just change this right here to a 43. Enter. So we've got 8 points right away. Pretty cool. Now what? It says configure appropriate addresses. Okay, we're doing IPv6. Configure branch with appropriate IPv6 addressing. B1 and B2 with appropriate IPv6 addressing using the first available address of the network to which it is attached. So what that means is we take this address and increment it by 1 So just make that a 2. Make that a 2. Okay, B1, I actually added these little labels in, so it helped me to keep things straight. So on the G00 interface, B1, so we just copy this one over here, and that gets incremented to 2. And then this one over here gets incremented to 2 as well. Just adding the default gateway. Okay, done there. These interfaces, add that in. Oh wait, that's not the subnet mask. Here's the subnet mask. And our, let's see, default gateway is right here. Now we just need to figure out what that is. Okay, let's go our addressing for IPv6 before we get carried away. Before I get carried away, you guys are always awesome. Know what you're doing, right? IPv6, what interface are we on? G01, copy that one. IPv6 address, paste that one in there. Enter. Then we will do this one up here. Copy. Paste that. Oops. Getting ahead of myself. Really getting ahead of myself. There. Now we did it. Now, I know we didn't get any points for that, but for whatever reason they didn't score us on that, even though they wanted us to do it, so don't worry about that. Now what they do want us to do, configure B1 and B2 with the appropriate IPv6. Oh, missed this part. Configure B1 with the appropriate IPv6 address using the first available address of the network to which it is attached. So, B1, we pull up our sheet again, our first available address in the B1, let's see, he was in that previous one, the 128. So our first available address would be 172.168, or 161.281. But is that correct? Is B1 on that one? No, B1's on the second one, so I had that right the first time. Duh. So that would be 144 and 1 for B1. Why don't I just pay attention? Let's do 240, 0. Alright, and here's our default gateway. Okay, got all that right. We got 17 points so far, so doing well. We got our addresses in here for our IPv6, so that's good. Now we need to add the IPv6 addressing for the two computers. So IPv4, let's do this. Copy, paste, 64, and then we'll just make that a 1. So that's the only difference. Again, I don't think we get any points for this, even though we're doing the correct configurations. And on this one, we just changed this to a 2. Where am I at? Yeah, just 2 there. 64, 1, and a 2. Whoops! Wrong line. Then it'll configure its own link local. Right? Yeah, I got it figured out. Okay. Got those done. Let's see what else we gotta get going. Document the address in the addressing table. We did that. What was? Oh crap! We didn't do that. We need one more address, don't we? All right, now we're done. Right? Right. Okay. Configure HQ and branch with OSPF version 2 routing for IPv4 according to the following criteria. Assign the process ID of 1, so we use OS router OSPF 1. Advertise all attached IPv4 networks. Do not advertise the link to the internet. Not that one. So don't put that network statement in. Configure appropriate interfaces as passive. So all of your black interfaces are going to be passive. So you have your G0 and G01. Oops, too far. Same thing on this side. The red ones you're going to leave on because they need to share updates in between each other. Duh. You knew that. Okay, so let's go to branch. Oh, come on. Router OSPF1. So our first network would be this one here, the 144.0 network. So network 172.16.144.0, and then we do our wildcard mask. Now, remember I told you to pay attention to that wildcard mask? Well, I wasn't. What was I doing? All right, so 15 to 55. 0, 0, 15 to 55. These are all going to just be in area 0. We'll do our up arrow. We're going to change this right here. I think it was 59, right? Or no, 28. Sorry, 28. 59 is the address of the router. 28 is the network we started off with. So we hit enter on that. And then we're going to have to share the route in between these two here. So it looks like we have a 192.168.0.0 network /30. So that's pretty easy. Remember those. 192.168.0.0 and those 000 and then a 3 to represent a /30. Area 0. Okay. Oh yeah, passive interfaces. Okay, well let's not forget those. G00, G01. Oh, I misconfigured this. So I'm going to say no here. And then turn this into a 2, not a 0. No, 8. 192.168. There. Now we did it right. Did it right that time. Okay, what's next here? What's next? So we did that on branch. Now we need to do on HQ. Same thing basically. We got one extra network to share about, but we won't. Not through the OSPF anyway. Okay, the first network that we are attached to. Okay, we've got a 18. Let's pull these up. So we've got 1600 and then 18. What is that? So that's a 63.255. That's what that wildcard mask would be. Network 172. What did I say? 63.255? Is that right? Sounds right. Yes. Oh, better add some zeros. Okay. Area 0. Up arrow, and we're just going to change this one variable right here. Come on, 64. For the next network up here, right there. And we'll do network 192.168.0.0. That's the link between the, that goes over to the other router. Okay. see what else we gotta do here. Let's see, configure. Set an IPv4 default route on HQ, which directs traffic to the S01 interface. Redistribute the route to branch. So before we leave this, let's do default information originates. Enter. And then, oh, wrong one. Okay, then we can X out of here. IP route, and into the quad zeros for the default route. Oh crap, I lost track. 1, 2, 3, 4. Okay. S0001, is that right? Yes. Alright, we're sitting pretty, guys. We're sitting pretty. Now comes the real tough stuff. Design an IPv4 named access list HQ server to prevent any computer attached to the Gigabit Ethernet 00 interface on branch, this guy's over here, from accessing HQ server PKA, this one right here. All other traffic is permitted. Configure the access list on the appropriate router, apply it to the appropriate interface, and in the appropriate direction. Okay, let's talk about this. We're going to be, because we're in CCNA 4 and we're talking about extended access control lists, we're not going to be using standard access control lists. We're going to be using extended. So yes, this can be done with regular access control lists, but because we're learning, that's the first clue. Open up branch. And where do we put extended access control lists? As close to the source as possible, that interface right there, because we want to keep this network from accessing this server, and it's an extended access control list. We put it as close to the source as possible. So we already know which router, we already know what interface. Now we just have to build the access control list itself. Okay, IP access list extended. Now we give it the name HQ server, and yes, these are case sensitive. Okay. HQ server, HQ server. Okay, we got it. We want to start this one off at a deny, because we're going to deny IP traffic from anybody on this network. So any traffic coming off of this network, doesn't matter who, to one particular destination, and that destination is HQ server right over here. So we need to get our access, or our IP address for that one. Oh, not the whole thing. There we go. And let's just separate that one little bit. I think we're done. We don't really, yeah, those two don't make any sense to us, so we're just going to leave those alone for now. Enter. So because access control lists have a deny, an implicit deny, we have to say all other traffic to any other location is permitted. So we say permit IP any. Okay, so that'll be our list. We just built our list. Now we have to go apply it. So let's get out of here, and we're going to go to interface G00. IP access group HQ server, and that is going to be in what direction? You guessed it, the in direction, or Y. It can be rather confusing when you're trying to figure out the different directions for an access control list. And why would I say that? Many people think that the in means when you're coming in, like coming from this direction this way into your network, or when you go out, it's from your network out to the internet, and that's not how that works. Imagine there's a little guy standing on top of the router. Traffic that's in is coming in to the interface, from his perspective. If you say out, it's going to be any traffic trying to leave that interface, whatever it is, so going out of the interface. So according to his perspective again. So we want to make sure that no traffic coming off of this network, it gets blocked right at the interface. So coming in. So enter, and we'll get our points. We're at 60. We're doing great. We're doing great. Next, access control list. Design an IPv4 access control list named branch server to prevent any computers attached to the Gigabit Ethernet 00 interface of HQ, right here, from accessing the HTTP and HTTPS service of the branch server. That's over here, so we don't want it. So basically the same thing, we're just going to be doing it on this interface, except, yeah, that's the only difference, right? All right. That, and we'll be using some different commands. We're going to be using some port numbers on this one. Let's open up HQ, IP access list. It's going to be an extended list, and we're going to call this list branch server. The first thing we're going to do is we're going to deny. We don't want any TCP connections because internet traffic is sent reliably with TCP. So no TCP of any kind on that network to a particular destination. What destination? The branch server, and his IP address is that one. Paste. Oh, hold on. We're going to say host. The host just means that it's this particular address. We don't need to offer a wildcard mask over here. So that's what that's all about. Okay, now we're going to do equals. So if the regular traffic coming out of here is fine, but if it's anything that goes off of port 80, we do not want that. That is blocked. That's HTTP. Also, we don't want the port number 443 being used, and that's secure HTTP. Enter. And then we want to permit IP traffic of any other kind. And that's fine. Anything else, that's fine. So we got some more points there. 75. On our way to the top. Let's get out of here. Interface G00, because we want to apply it extended. Remember, extended gets applied to the closest interface according to the source. IP access group branch. Ooh, hold on. Branch. I'm just struggling. Branch server. Again, we'll do the in. Okay. Exit out of there. One last one here. Design an IPv6 access list named No B1. Poor little B1. To prevent any IPv6 traffic originating on B1 to reach the branch server.pka. It's over here. Like I said, I should move over a little bit. No traffic should be permitted from B1. So just him. He's the only one singled out. To branch server PKA. Apply the IPv6 address or access to the most appropriate location, interface, and direction. This had me really confused for a little bit because it's not, in my mind, the best interfaced or in the best direction. Instinctively, I would say, oh, extended. Well, of course, we need to put that on this interface, the G00 interface in the in direction, because we're going to stop it before it gets routed. Saves network bandwidth, saves some computation on the branch router. But no, we're going to actually assign it to this interface. Why? I don't know. That's just the way this packet tracer was built. If you have a better explanation for why, please tell me, because I'm curious. Other than they just wanted to use up all the interfaces. Okay. Let's get out of here, and we're going to do one more of these access lists. Oh, hold on here. IPv6 access list. That's what we want. We're going to call it capital NO dash capital B capital 1. And we're going to say deny, and then the host that we are going to deny is IPv6 host is B1. So B1, we're just going to take this, not that, this portion of the address, paste it in there, and we're going to say going to host, and then give him the address of branch server right there. Copy, paste, and press enter. And then we'll permit IPv6 any. Okay. So that's right. Now let's do interface 201 IPv6 traffic filter. Now this is a different. It's basically the same thing as saying access group for IPv4 interface, but this is traffic filter. So it means the same thing. And we're going to give it our name. Oops, no, capital B1, and then in the out direction. Because if we're trying to block his traffic going to here, we have to stop it either here or here. So we're going to stop it in the out direction, coming out of the interface, going to branch server. Press enter, and we've got our 100 points. So thank you very much for watching. If you have any questions, please put them in the comment section below. If you haven't already, hit that subscribe button because I really appreciate it. I love giving you guys information about packet tracers and the Cisco world. So if you've got anything for me, send it on over to whalehater@gmail.com, and I will respond if you've got some questions that you don't want to put in the comment section, but I appreciate it if you do, and other people like reading those as well. But if you also want a copy of that IPv6 or IPv4 addressing schematic thing that I use all the time, I really love using it. It saves brain power and time, and you guys can have a copy. Just email me at that same address. All right. Yeah, that's it. Peace.